So let's analyze the question. You throw a stone horizontally at a speed of 5 meters per second then. Because of the units meters per second, we know we have a velocity variable. Continuing on, from the top of a cliff that is 78.4 meters. So we now know we're dealing with displacement here. So go ahead and underline that. And 78.4 meters high. So the object, a stone is falling from the top of a cliff that has some height. So the variable is referring to here is going to be displacement now. The key word here, horizontally, actually gives us a lot of detailed information. So the first thing, it lets you know that if we draw my cliff, right, the stone is being thrown like this compared to, let's finish off the cliff, by drawing cliff, compared to this, all right. When it's being thrown horizontally, it means that the initial velocity in the y direction is actually going to be 0 meters per second because there is no y component when it's thrown like this. But when it's thrown at an angle, you have an x component, which I'm going to draw right here, and you're going to have a y component, which is going to be here. In this problem, the initial velocity is only going to be just the x component, which is this. So this means that the initial velocity in the x direction is going to be 5 meters per second. All right, so I'm going to go ahead and put this initial velocity in the x direction. I'm going to let it be positive 5 meters per second. The initial velocity in the y direction, I'll go ahead and let that be 0 meters per second. We also have a height. Since it's falling from the cliff, and we're going to let this be the origin, that means it's going to fall below. That means it's going to be a negative 78.4 meters then. So the displacement is going to be negative 78.4 meters. All right. There are also a few unknown givens that we don't know or can't see. First one is that the acceleration in the x direction is always going to be 0 meters per second square. And the acceleration in the y direction is always going to be negative 9.8 meters per second square. Right? So now moving on to our unknown, part A. Part A is asking us how long does it take the stone to reach the bottom of the cliff. So the keywords how long, that tells you that you're looking for time. So for part A, time is going to be your unknown. For part B, how far from the base of the cliff does the stone hit the ground? So when the stone is being thrown, it's going to be thrown like this, and it's going to just fall right here. This is where it lands. So part B is asking us, what is this length right here, which is the x displacement then? So this right here, how far, this is represent with the x variable. So we're going to put this as my unknown. Part C, what are the horizontal and vertical components of the stone's velocity just before it hits the ground? So what are the horizontal and vertical components just before it hits the ground then? So just before it hits the ground is trying to refer to the final velocity. So I'm going to put final V. And so it needs the velocity component in the x direction. So it could be VFX equals unknown and VFY equals to unknown. So for part A, we're going to have to figure out which of these equations we need to use then. So for this part, we need to find time. So for the equation, we need to have time in the equation then. So time is here, here, here. Time is here, here, and here. So that means I could eliminate this equation, and I could go ahead and eliminate this equation then. The next key element is notice that I need the displacement in the y direction. So automatically, this is out, and this is out, because these are dealing with the x direction. So in this one, these three down here, there is my y variable. There's my y variable here. This one does not have the y variable, so I'm going to eliminate this one right here. And notice that I'm going to need my acceleration. So it looks like acceleration I need, it's right here. And because this equation does not have acceleration, I'll go ahead and eliminate this. And notice that I do have initial velocity in y, and this does have time. So this is going to be the equation I'm going to need to solve this problem then. Okay, so I chose y is equal to initial velocity in y times time plus 1/2 a in the y direction times square. All right. Notice that we can eliminate some of our variables because we know we're given initial velocity to be 0, and we know this is going to be 0 meters per second. So this term right here is going to drop out for us. So I'm going to go ahead and rewrite the equation right now. Y is equal to 1/2 at squared. I'm going ahead and solve for time. So I'm going to multiply both sides by 2. So this 2 and this 1/2 cancels. I'm going to get 2 times y is equal to at squared. Divide both sides by a. A crosses out. I'm left with 2y over a equals to t squared. I'm going to get rid of this square. I'm going to square root both sides then. So I'm going to be left with time is equal to square root of 2 times y over a. So using our equation from the previous slide, we have square root of 2 times y over a equal to time. We'll go ahead and plug in our values then. So the square root of 2 times negative 78.4, divide that all by negative 9.8. Let's go ahead and multiply 2 times negative 78.4. So that should give you a negative 156.8 divided by negative 9.8. Divide a negative 156.8 divided by negative 9.8. The new two negatives will negate each other, so you're going to have a positive number. And dividing these two, you should get positive 16 then. And when you take the square root, you're going to end up with a plus or minus 4. But because time is not going to be negative, we're going to keep the plus 4 then. So time, okay, will be 4, or in our case, it's going to be 4 seconds then. So for part A, time is going to be 4 seconds. Looking at our time, it's not a negative number, it's not a really big number, it's not a really small number, so our answer does seem to make sense then. So from part A, we know that the time it takes for the stone to fall from the top of the cliff is going to be 4 seconds. So I'm going to put that here. But the time is also going to be the same for in the x direction too then. So if the stone was to travel horizontally, it will only travel for 4 seconds. So looking at our unknown, we're going to start with this. We see that we need the x variable, the x displacement. So that means that the equations in the y direction, we won't need them because we're working with x, not y. So I'll cross them all out. And then notice that this equation I may use, this equation I will not use. This one I will use because there's the x displacement, and this one I might use. So next part, I need the initial velocity. So this one has the initial velocity, this one has the initial velocity, this one has the initial velocity. I also need final velocity. This equation has final. This one doesn't have the final velocity, and this one has final velocity. Finally, I'm going to need my time. This equation will have time. This equation does not have time. Now I could go ahead and eliminate this, but it does have acceleration, which we have here. But the problem with this equation is that we've used this one right here and plug in our acceleration as 0. This term will just drop out, And then you're just left with this is equal to that. And that's not going to help us in this case, so this is why this equation is eliminated then. So our best option is to use this equation right here. So now I'm going to rewrite my equation. So from the last slide, we know that we're going to use this equation. Displacement is equal to 1/2 times initial velocity plus final velocity times time. Now, fortunately for us, we don't have to do any rearranging because the unknown or the displacement is already by itself. So we don't even have to make any changes to it then. We could go ahead and move on to step 3. So I'll go ahead and rewrite the equation one more time. Initial velocity in x plus final velocity in y times it by time. I'll go ahead and plug in our values. So 1/2 times 5 plus 5 times it by 4. I'll go ahead and add the 5's together. That gives me 10 times 4. 1/2 times 10, that gives me 5 times 4. And then 5 times 4, 20 then. So because it's displacement, we know the units for displacement is going to be meters. And that is our answer. So just to double check our answer, 20 meters, always check the sign. For our case, it's going to be positive, which will make sense. If it was negative, that means it's going behind the cliff. And notice it's not too big, all right, not in the range of 1,000,000, and it's not too small, like 2 meters. So our answer does check out then. So from part B, we know our answer for the displacement is going to be 20 meters, so I'll add that to our list of givens. And for part C, we need the final velocity in x direction, and we need the final velocity in y direction then. So we actually know the answer for final velocity in x, because that is our given right here. But to remind you how we got this answer, remember that the acceleration in x direction is 0 meters per second squared for our case. So if its initial velocity is plus 5 meters per second and acceleration 0, this velocity does not change as the rock is dropping from the top of the cliff to the base of the cliff. So that means that the final velocity in x direction should be the same as the initial velocity then. So that means it's going to be plus 5 meters per second. Now to get the final velocity in y, it looks like we need a kinematic equation. And since I'm working in the y direction, I could go ahead and eliminate all of the equations for x. And going down the list of our kinematic equations for y, I know that I could use this equation. I know I could use this equation. This equation I can't use because final velocity in y does not exist. And then I could use this equation right here. So going to our list of givens in the y direction, I need the initial velocity in y. It's given here, it's given here, and it's given here. So that doesn't eliminate any equations. I know I need to use displacement. Displacement's here. Displacement is not given here, so I could cross this one out. And displacement is given here then. And moving on, I have the acceleration then. Acceleration is not given here, but it's given here. But notice that we do have time. The time is given as 4 seconds. So for this part, we could actually use either this equation or this equation. I'll go ahead and just use the fourth equation down here. All right, using the fourth equation, I'll go ahead and write out here, final velocity squared is equal to initial velocity in y squared plus 2 times acceleration in y times the displacement in y. Let's go ahead and solve for the unknown. In our case, our unknown is going to be the final velocity in y. So to get rid of this square, I'm going to square root both sides then. So if I square root the left side, I'm going to be left with just final velocity in y. And for this term, I'm going to just be left with initial velocity in y squared plus 2 times acceleration and and the y displacement then. So I'll go ahead and rewrite my equation one more time. It's equal to square root initial velocity in y squared plus 2 times acceleration y times y. I'll go ahead and plug in my values then. I'll plug in initial velocity, which is going to be 0, very nice, plus 2 times the acceleration, negative 9.8, plug in negative 78.4 meters right here. I'll go ahead and simplify the equation. 0 squared just becomes 0. You have a negative times a positive, you're going to get a positive number. And 2 times 9.8 times 78.4, I get 1,536.64. 0 plus that means I'm going to just get the same number, 1,536.64. The square root of this number will give me a plus or minus 39.2 meters per second. And so this is my final velocity in y. Now notice I have two signs, a plus and a negative. Now since we have the cliff, and this is our origin right here, and the stone is falling like this, close to that, its y component is going to be negative because it's going in the downward direction. So I'm going to take the negative sign of this. So our final answer will be final velocity is negative 39.2 meters per second then. Looking over our answer then, I got negative 39.2 meters per second. First thing I want to double check is the sign correct. And because the stone is going downward in the y direction, it should be negative. And I got to double check to see is the number too small or too big. And so in our case, 39.2 seems about right. And so this is our answer, negative 39.2 meters per second.